Okay, question 19. A sample of mercury occupies a volume of 2.43 milliliters. So, let's see, what am I given here? 2.43 milliliters, that's the volume. And I'm also told that the density is 13.6 grams per milliliter. What do I want? I want to know the mass in grams. So I have to use these two pieces of material to eliminate milliliters and leave me with grams. So I start with this one. I need to know, I want to keep grams, is my answer. I need to eliminate milliliters. So if I simply multiply by 2.43 milliliters, I can cancel those milliliters, and that leaves me with gram. And if I do that, that equals, what comes out of my calculator is 33.048, and the units I'm left with are grams. Now, significant figures, 3 significant digits here, 3 significant digits here. This can only have 3 significant digits, so I'm going to, this is less than 5, so this becomes 33.0 grams, and that's my answer for number 19. Now, here's a problem where I'm given the data on 4 different samples, lithium, gold, aluminum, and lead. I'm given those densities. And then the question says, if all of these samples have the same mass, which one occupies the largest volume? So let me just put this to you a different way. I know you've gone to the store and you've bought those styrofoam coolers, right? Empty styrofoam cooler. Styrofoam, I don't even know how to spell it, foam. And let's say I weigh it, it weighs, I don't know, it isn't going to weigh very much, right? A big cooler has a low density, and that is going to weigh a certain amount. Now I compare that with something that's much more dense. So what if I have a piece of gold here, right? To weigh the same amount, it's going to be a much smaller volume. So things that have small densities tend to occupy more volume, and that's what this one, which one of these, given the same mass, occupies the largest volume, and that's going to be the least dense one. Let's just try and prove that. Let's do a calculation to demonstrate that. So we'll start with lithium, and lithium is 0.53 grams for every 1 milliliter, but we want to ratio this. If all the samples have the same mass, which one occupies the largest volume? So we're going to flip that over, and we're going to actually write that as 1 milliliter for every 0.53 grams. And then let's just to make a comparison, let's call all these samples 10 grams. We do that, this one's going to turn out to be 10 divided 0.53, and that's going to give me 18.9, about 18.9, and the units are milliliters. And let's compare that with the most dense one, which is gold, right? 19.3. So let's do the same thing for gold, and that's going to be, I have to flip that over, remember, so it's one for every 1 milliliter, I have 19.3 grams for gold. Multiply that by the 10 grams to cancel. So you see we're doing a ratio into the same mass here. And when I do that calculation, now that one is much smaller. That turns out to be 0.52 milliliters, right? So the more dense things packed into a smaller space for the same mass. And the answer is going to be the lowest density, right? So lithium in this case. Lithium is the answer to question 20.